Imagine searching for a specific topic in a massive encyclopedia with no table of contents. You'd be flipping through pages endlessly, wasting valuable time. This is where the power of organization comes in. A well-structured table of contents acts as a roadmap, guiding you directly to the desired information. In the world of SQL Server, clustered indexes play a similar role. They provide a way to organize data physically, making data retrieval faster and more efficient. This comprehensive guide will delve into the world of clustered indexes, unraveling their intricacies and empowering you to optimize your SQL Server databases for peak performance. At its core, a clustered index in SQL Server is a special type of index that dictates the physical storage order of data within a table. Unlike non-clustered indexes, which create a separate structure with pointers to the actual data, a clustered index directly determines how data is arranged on the disk. This fundamental difference is key to understanding the power and implications of using clustered indexes. Clustered indexes are fundamentally different from their non-clustered counterparts in how they organize data. While non-clustered indexes create separate structures pointing to data locations, clustered indexes directly dictate the physical order of data rows within a table. This inherent connection between the index and the physical storage is crucial to understanding how clustered indexes work and how they impact database performance. Imagine a library where books are randomly scattered on shelves. Finding a specific book would require a tedious search through every shelf. Now picture that same library with books meticulously organized by author and title. Locating a specific book becomes significantly faster and more efficient. This analogy perfectly illustrates how clustered indexes transform data retrieval in SQL Server. A fundamental requirement for creating a clustered index is that the indexed column must contain unique values for each row in the table. This is because a clustered index is not just a simple list of pointers to data. It actually determines the physical order of data in the table. This uniqueness constraint stems from the very nature of how clustered indexes organize data physically. When you create a clustered index, SQL Server rearranges the data rows in the table to match the order of the index. This means that the data is stored in the same order as the index, making data retrieval much faster and more efficient. Since the clustered index directly determines the physical order of rows, having duplicate values in the indexed column would lead to ambiguity in data storage and retrieval. Imagine trying to find a specific book in a library where multiple books have the same identifier. It would be chaotic and inefficient. To understand this concept, consider a library shelf organized by author's last name. The organization of books in a library is a good analogy for understanding how clustered indexes work. Just as books are arranged in a specific order to make them easy to find, data rows are arranged in a specific order in a clustered index. If two authors share the same last name, placing their books on the shelf solely based on that criterion would create confusion. You wouldn't know which book belongs to which author without additional information. We need additional information, such as the author's first name or book title, to distinguish and order them correctly. This additional information acts like a secondary key that helps in organizing the books more precisely. Similarly, a clustered index relies on the uniqueness of values in the indexed column to establish a clear and unambiguous physical order for the data rows. Without this uniqueness, the database system would struggle to maintain an efficient and reliable order, leading to slower query performance and potential data integrity issues. Therefore, ensuring that the indexed column has unique values is crucial for the effective functioning of a clustered index. In summary, the uniqueness of the indexed column in a clustered index is not just a technical requirement, but a fundamental principle that ensures the database operates smoothly and efficiently. By maintaining a unique and orderly structure, clustered indexes significantly enhance the speed and reliability of data retrieval operations. The true power of clustered indexes lies in their ability to significantly accelerate data retrieval operations. particularly for queries that involve filtering or sorting data based on the indexed column. This is especially crucial in large databases where the volume of data can be overwhelming. Without clustered indexes, retrieving specific information would be akin to finding a needle in a haystack, requiring extensive scanning of data blocks. This performance boost stems from the physical ordering of data imposed by the clustered index, which allows SQL Server to locate and retrieve the desired information with remarkable efficiency. By organizing the data in a structured manner, clustered indexes reduce the time and computational resources needed to execute queries, thereby enhancing overall system performance. Imagine searching for a specific word in a dictionary. The dictionary is organized alphabetically, making it easy to find the word you are looking for without having to read through every single entry. This analogy perfectly illustrates how clustered indexes function in a database. Thanks to the alphabetical order, you can quickly flip through the pages and locate the word with ease. Similarly, clustered indexes allow SQL Server to quickly navigate through the data, pinpointing the exact location of the required information. Clustered indexes offer a similar advantage in the database world. They ensure that the data is stored in a logical sequence, which is particularly beneficial for range queries and sorting operations. This logical sequence is maintained even as new data is inserted or existing data is updated, ensuring consistent performance. When a query involves a where clause that filters data based on the clustered index column, SQL Server can leverage the index to directly pinpoint the relevant data blocks on the disk. This direct access minimizes the need for full table scans, significantly speeding up query execution times. In essence, clustered indexes transform the way data is accessed and retrieved, making database operations more efficient and responsive. To truly grasp the power of clustered indexes, it's helpful to understand how they are structured and organized internally. Clustered indexes are a fundamental component of database management systems, playing a crucial role in how data is stored, accessed, and retrieved. By delving into their internal structure, we can appreciate the efficiency they bring to database operations. While the specifics might vary slightly depending on the database system, the underlying principles remain consistent. Whether you're working with SQL Server, MySQL, or Oracle, the concept of a clustered index is universally applicable. Understanding these principles can help you optimize your database performance across different platforms. At its core, a clustered index resembles a B tree, a self-balancing tree structure designed for efficient data storage and retrieval. The B-tree structure is a widely used data structure in computer science, known for its ability to maintain sorted data and allow searches, sequential access, insertions, and deletions in logarithmic time. The B-tree structure consists of multiple levels of nodes, with the root node at the top and leaf nodes at the bottom. This hierarchical organization ensures that data can be quickly located by traversing from the root to the appropriate leaf node, minimizing the number of disk accesses required. Each node in the B-tree represents a range of values within the indexed column. These ranges are carefully managed to ensure that the tree remains balanced, with each node containing pointers to its child nodes, facilitating efficient navigation through the tree. The leaf nodes of the B-tree hold the actual data rows of the table, physically ordered according to the indexed column. This physical ordering is what distinguishes a clustered index from a non-clustered index, where the data rows are stored separately from the index. These leaf nodes are linked together, forming a doubly linked list that allows for efficient, sequential access to the data. This linkage is crucial for operations that require scanning through a range of values, as it enables the database engine to move smoothly from one data row to the next. This linked list structure is crucial for range-based queries, enabling SQL Server to quickly traverse through a specific range of values within the indexed column. By leveraging the doubly linked list, the database can efficiently handle queries that involve sorting, filtering, and aggregating data over a specified range, significantly improving query performance and response times. Selecting the appropriate column for your clustered index is arguably the most critical decision when implementing this powerful optimization technique. The chosen column directly influences the physical data layout and significantly impacts the performance of various database operations. Striking a balance between query efficiency and the potential overhead on data modification operations is key to maximizing the benefits of clustered indexes. In today's data-driven world, speed is paramount. Users expect instant results, and applications demand quick access to vast amounts of information. This is where clustered indexes truly shine, acting as turbochargers for your SQL Server queries by dramatically accelerating data retrieval. Storage costs are a significant concern for organizations dealing with massive datasets. While storage capacity continues to increase, efficiently managing and optimizing data storage remains crucial. Surprisingly, clustered indexes can play a role in data compression, helping you make the most of your storage resources. Data integrity is paramount for any database system. Ensuring that data is accurate, consistent, and reliable is crucial for making informed decisions and maintaining data quality. Clustered indexes, beyond their performance benefits, provide a robust mechanism for enforcing unique constraints, safeguarding your data's integrity. Section 4. Beyond the obvious additional benefits. While faster data retrieval, data compression, and unique constraint enforcement are the most prominent advantages of clustered indexes, several less obvious benefits further enhance their value in a SQL Server environment. These benefits might not always be the primary motivator for choosing a clustered index, but they contribute to a more efficient and well-optimized database system. Section 5. Real-world scenarios where clustered indexes shine. Understanding the theoretical benefits of clustered indexes is essential, but seeing them in action within real-world scenarios truly highlights their practical value. Let's explore a few common use cases where clustered indexes prove particularly advantageous, demonstrating their impact on database performance and efficiency. Section 1. Identifying ideal candidates, when to consider clustered indexes. Deciding when to implement a clustered index requires careful consideration of various factors, including your database design, query patterns, and data modification characteristics. While clustered indexes offer significant performance advantages, they are not a one-size-fits-all solution and should be strategically employed to maximize their effectiveness. Section 2. Frequent queries, the cornerstone of clustered index benefits. The most compelling reason to implement a clustered index is to accelerate frequently executed queries. If a specific column consistently plays a pivotal role in your query, where clauses join conditions or order by clauses, a clustered index on that column can significantly reduce query execution time. Section 3. Join operations, bridging the gap with clustered indexes. Join operations, a fundamental aspect of relational databases, combine data from multiple tables based on a shared column. When these tables involve substantial amounts of data, join operations can become performance bottlenecks. Clustered indexes, strategically placed on the join columns, can significantly expedite these operations. Section 4. Order by and group by, leveraging inherent order for efficiency. Order by and group by clauses are common elements in SQL queries, enabling you to sort and group data based on specific criteria. When these clauses involve the column that defines the clustered index, SQL Server can leverage the inherent order of the data, leading to substantial performance improvements, especially for queries dealing with large data sets. Section 5. unique constraints, a natural fit for clustered indexes. Maintaining data integrity is paramount for any database system. Unique constraints ensure that a particular column or a combination of columns contains only distinct values, preventing duplicate records and ensuring data accuracy. Clustered indexes provide a natural and efficient mechanism for enforcing unique constraints. Section 1. The DML dilemma: navigating the trade-offs. While clustered indexes are renowned for their ability to accelerate data retrieval, they introduce a trade-off that must be carefully considered: the potential impact on data manipulation language operations such as insert, update, and delete statements. Understanding this trade-off is crucial for making informed decisions about clustered index implementation. Section 2.1. Index to rule them all. The limitation of singularity. A fundamental limitation of clustered indexes in SQL Server is that a table can have only one clustered index. This restriction stems from the very nature of clustered indexes. They physically define the storage order of data rows within a table. Having multiple clustered indexes would imply multiple physical orderings, which is logically impossible. Section 3. Data type considerations. Choosing wisely for optimal performance. The data type of the column you choose for your clustered index can subtly yet significantly impact the index's efficiency and the overall performance of your database. Understanding the nuances of different data types and their implications for clustered indexes is crucial for making informed design decisions. Section 4. Fragmentation, the silent performance killer. Fragmentation, a common issue that can plague clustered indexes, occurs when the logical order of data pages within an index no longer aligns with their physical order on the disk. This misalignment can significantly degrade query performance, as SQL Server needs to perform additional I/O operations to retrieve data that is scattered across the disk. Section 5. Monitoring and maintenance. Keeping your indexes in top shape. Creating a well-designed clustered index is just the first step. To ensure long-term performance and efficiency, it's crucial to establish a robust monitoring and maintenance strategy for your indexes. Regular monitoring helps you identify potential issues such as fragmentation or outdated statistics, while timely maintenance ensures that your indexes remain in optimal condition. Striking gold. Choosing the right column for your clustered index. Selecting the optimal column for your clustered index is akin to a gold prospector meticulously examining potential sites for the richest veins. The right choice can unlock a treasure trove of performance gains, while a misstep might leave you with a barren landscape of inefficiency. The perils of update frenzy. Minimizing the impact of data modifications. While clustered indexes excel at accelerating data retrieval, they are not immune to the performance implications of frequent data modifications. Excessive updates, inserts, or deletes can disrupt the carefully crafted order of a clustered index, leading to fragmentation and reduced efficiency. Performance, vigilance, monitoring clustered index health. Much like a physician regularly monitors a patient's vital signs, a diligent database administrator keeps a watchful eye on the health of their clustered indexes. Performance degradation can be subtle and gradual, making proactive monitoring essential for identifying and addressing potential issues before they escalate into major problems. Section 4. The fragmentation foe. Understanding and combating index. Fragmentation. Fragmentation, a common ailment that can afflict clustered indexes, is akin to a library where books are haphazardly shelved out of order. Finding a specific book becomes a time-consuming endeavor as the logical order no longer corresponds to the physical arrangement. Section 5, the maintenance ritual, keeping your clustered indexes in peak condition. Maintaining a clustered index is not a one-time endeavor, but rather an ongoing ritual, much like a gardener tends to their prized rose bushes with regular pruning and care. Neglecting index maintenance can lead to performance degradation, reduced efficiency, and a host of other issues that can hamper your database's well-being. Section 1, the power of clustered indexes, a recap. Throughout this comprehensive guide, we've embarked on a journey into the intricate world of clustered indexes in SQL Server. We've explored their inner workings, unraveling the mystery behind their ability to transform data retrieval speeds and elevate database performance to new heights. From the fundamental concept of physical data ordering to the nuances of index fragmentation and maintenance, we've delved into the essential aspects that empower you to harness the full potential of this powerful indexing technique. Section 2, embracing clustered indexes, a path to optimization. Mastering clustered indexes is not merely about understanding their theoretical underpinnings. It's about embracing them as indispensable tools in your SQL Server optimization arsenal. By carefully considering the factors we've discussed and adopting a strategic approach to their implementation and maintenance, you can unlock significant performance gains and elevate your database's efficiency to new heights.